Hello, before the demo, I would like to explain how I use Codex and GPT 5.6 in my project. Codex, I used it as my hands-on development partner. It helped me explore project in all possible directions, right from building the Next.js application, debugging issues, testing the accessibility workflow, improving the interface, and also preparing deployment and documentation. GPT 5.6 helped me throughout that Codex workflow for technical reasoning, code generation, debugging, test case design, and product iteration. It helped turn feedback from real tests into concrete improvements. The result is AccessTrace. And now I introduce you AccessTrace. First, let us discuss the issue. Accessibility bugs are often introduced during normal product updates, right? A button can lose its accessible name, a form field can lose its label, or keyboard navigation can change. The page may still look completely fine, but it becomes harder or impossible to use with a keyboard or screen reader. AccessTrace is built to catch those regressions before release reaches users. So here, currently we are on Playground. It says find the regression, not just the rule. So on the left is the baseline, which represents a known good accessible version of a page. On the right is the candidate in current branch, which represents the changed version that developer is about to release. In this checkout example, the candidate has knowingly introduced two common but serious issues, just so that we can see and understand from example how AccessTrace is functioning. The coupon field has now has only a placeholder instead of persistent label, and the place order button has no readable name because its visible text was removed. When we click on run comparison, AccessTrace does not simply list every possible accessibility rule. It compares the candidate against baseline and shows only the regressions introduced by the change. It also maps keyboard journey, the screen reader findings, and the semantic structure of the page, including headings and landmarks. We can see, and I would like to bring to your notice, currently it says 2 regressions and it flags the need of attention. But below this, it gives a safe fix preview. And on up, that means it is not just diagnosis, but it also gives solution. When we click on apply patch, it has changed the candidate current branch. It has reduced the regression to 1, but it still needs attention. The moment we apply the patch again, the second patch, it has changed the code again. No new regressions and save to merge. Voila! We have achieved our result. Now we move to another interesting feature, that is browser scan. Here we are on browser. When we give it a link, a real working link, a real live URL that is available on internet, we can check any URL, but it runs best on local environment currently. It opens a live URL in Chromium, waits for the page to render, and follows a real-time focus. It would take just 10 to 15 seconds because this allows developer to inspect the keyboard journey, right? A user actually experiences instead of relying only on static HTML. So here it says that the already live website has 4 issues. It also has shown 17 keyboard stops, 5 rendered headings, and 2 landmarks. We can see clearly that the browser scan is actually a very reliable partner to test live URLs, right? We built this AccessTrace with Next.js, React, TypeScript, Playwright, and most importantly, Codex and GPT 5.6. Codex and GPT 5.6 has helped us move through all the phases, right from original idea through implementation, browser testing, debugging, and design iteration. Codex and GPT 5.6 have really proved to be a very reliable partners for every developer. I would like to reiterate my goal at the end. That goal is simple: make accessibility regressions visible, understandable, and fixable before users encounter them. Thank you.